2025 A-Level Combined Mathematics Paper 1 Part B Question number 16 Part 1. Question number 16 actually doesn't have any Part A's or Part B's unlike all the other questions that we've seen so far. But if I were to cover the entire question number 16 in one video, it would be too long. For that reason, I have broken the first 3 lines of question number 16 into Part 1, which I will be discussing in this video. And the next 4 lines of this question have been broken into Part 2, which I will be discussing in the next video, link in the top right. Part 1 has to do with straight lines on the coordinate plane. If you look at the particular question, it says let O be the origin and let the point A be 1, 2 and let the point B be given by 5 over 2, 5 over 4. Given this, we are asked to find the equations of the angle bisectors of the angles AOB and the angle OAB and show that these angle bisectors intersect at a point D, which is 5 by 4, 5 by 4, and given that, we are asked to find the perpendicular distance from D to the line OA. Now, to start off with this part of the question, let's just draw the situation that we have here. We'll draw the points, and that will give us a better understanding of what we're actually trying to solve. So, if you consider the points, the point A is 1, 2, which if we call this, let's say 2, this say a 1, it's going to be approximately over here. So, A is the point given by 1, 2, which is over here. Now, as the point B is 5 over 2, 5 over 4, or 2.5, 1.25, which is going to be approximately somewhere over here. So, the point B given by 5 divided by 2, 5 divided by 4. Now, I'm also additionally going to connect the origin here 0, 0 to the point A. I'm going to connect the origin to the point B, and I'm going to connect the point A to the point B like so. Now, given this, we can see that the angles that we want, the angle AOB and OAB, are clearly visible. The angle AOB, this angle here, is this point, this angle at this point here, and the angle OAB is going to be OAB, which is this angle right here. Now, we are asking for the angle bisectors of these two, and if we just take a look, we can see visually that the angle bisectors we're looking for are this angle bisector that goes like this, and this angle bisector that goes like this, and therefore the point of intersection of those two angle bisectors, which we are calling D, is going to be this point right here. So I'm actually going to draw this out. I'm going to draw this point right here. I'm going to call this point D, and additionally I'm going to call this angle bisector L1, and I'm going to call this angle bisector L2, just for the sake of having a label for it that we can then refer to in our question. So now we will label the point of the origin, we will label the point A, the point B, and additionally we will also label the point D and the two angle bisectors that we're going to be looking for, which is L1, which is the angle bisector of AOB, and L2, which is the angle bisector of OAB. Now, additionally to this, usually when you're drawing something like this, you want to make declarations. So I'm going to declare let L1 be the angle bisector of the angle which is O, actually not O, AOB, and L2 be the angle bisector of the other angle which is OAB. So OAB. And there we go. We've defined the two angle bisectors L1 and L2. Now we can start to work towards finding the equations of L1 and L2, and we're ideally going to have to find these in the form of AX plus BY plus C equals 0. Now, in order to find these, what I'm actually going to have to do first is to find the equation of the lines OA, AB, and OB. And the reason for that is that once we find these lines, we then have a formula which you will recall from the video that we can use to find the equations of the angle bisectors L1 and L2. Now, considering these 3 lengths OA, the line OA, the line OB, and additionally we also want to find the line AB, which I'm going to write down somewhere here. If we start considering these, for the line OA, we can see the point A and the point O on the line OA, which means we can take these 2 points for our gradient. If you consider these 2 points, we can see the y value here is 2, the y value here is 0, so we have 2 minus 0. Divide by the x value difference, which is going to be 1 minus 0, and this must be equal to the y value difference divided by x value difference for any other point x, y on the line OA. Now, considering that, we can see how if we consider the point O and any random point x, y, that y minus 0 divided by x minus 0 is also going to be equal to the gradient. So therefore, y minus 0 divided by x minus 0 is going to be equal to 2 minus 0 divided by 1 minus 0. Now we can see this will all simplify. On the left hand side we'll have y divided by x. On the right hand side we'll have 2 divided by 1. Which means if we cross multiply, y is going to be equal to 2x, which if I take to the other side and simplify into the form of ax plus by plus c, we can see, I'm going to skip a few steps here, but you can see how this is going to be equal to 2x minus y equals 0. You can see this because if you take this x to the other side, we have 2x. Here we have y. So we have y equals 2x. If I take to the 2x to the other side, y minus 2x equals 0, which I could write as 2x minus y equals 0. So therefore, this right here is the formula for any point x comma y which is on the line OA. Now similarly, if we consider OB, for OB we can take the points O and B, and if we take those coordinates, we can see that the gradient is going to be the y coordinate difference, which is going to be 5 over 4 minus 0 divided by the x coordinate difference, which is going to be 5 divided by 2 minus 0. So 5 divided by 2 minus 0. And if we consider the point origin O and a random point x comma y on this line, we can see how y minus 0 divided by x minus 0 has to be equal to 5 over 4 minus 0 divided by 5 over 2 minus 0. Now if we evaluate this thing, we can see 5 divided by 4 divided by 5 divided by 2 is going to be equal to a half. So this is equal to a half, which means that y divided by x is going to be equal to a half. Now we can see, if we do the same thing we did for the above equation and we simplify down, we can see that we get that OB is given by, and I'm going to skip again a few steps here, but you can see if I take this 2 here, we get 2y equals x. So 2y equals x, I'm going to take the x to the other side, which gives us 2y minus x equals 0, which I'm going to write as x minus 2y equals 0. So there we go. Once again, we have the form ax plus by plus c equals 0. Now finally, if we consider AB, for AB, if we take the gradient, we can take these 2 points, the 1, 2, and 5 by 2, 5 by 4. If we take those 2 points and we consider the gradient, we can see we are going to have a y coordinate difference of 5 by 4 minus 2 divided by 5 by 2 minus 1. So we can have equal to 5 by 4 minus 2 divided by 5 by 2 minus 1. This is going to be equal to the y coordinate difference of y and 2, so y minus 2 divided by the x coordinate difference of x minus 1. So we can have y minus 2 divided by x minus 1 equal to all of this. Now we can see, if we simplify this thing, which I'm actually going to do in multiple steps because it's a little bit more complicated than the previous ones. If we simplify this thing, we can see the 2 can be turned into an 8 divided by 4, which if you subtract 5 divided by 4 minus 8 divided by 4, we're going to have minus 3 divided by 4. On the denominator, we're going to have 5 divided by 2 minus 1, which is going to be 5 divided by 2 minus 2 divided by 2, which is going to be 3 divided by 2. Which if you simplify, we can see negative 3 over 4 divided by 3 over 2 is going to be negative 1 over 2. So we get negative 1 over 2, which means that y minus 2 divided by x minus 1 is equal to negative 1 over 2. Cross multiplying, we can see that 2y minus 4 must be equal to 1 minus x. Now we can see, if we take everything to one side, we have x plus 2y minus 5 equals 0. So therefore AB is given by x plus 2y minus 5 equals 0, which is of the form ax plus by plus c equals 0. So we can see we have all three lines OA, OB and AB in the form of ax plus by plus c equals 0, which is important for our next step. So it's important that we do this because we know that if we have two lines, which I'm going to write that if we have two lines, one line being u1, let's say, which is of the form a1x plus b1y plus c1 equals 0, and another line u2, which is of the form a2x plus b2y plus c2 equals 0. If we have this, then the angle bisectors of u1 and u2, and remember there are two angle bisectors, there's the acute angle bisector and obtuse angle bisector. The two angle bisectors of u1 and u2 are given by the formula a1x plus b1y plus C1 divided by the square root of A1 squared plus B1 squared equals plus or minus A2x plus B2y plus C2 divided by the square root of A2 squared plus B2 squared. So this relationship holds. One of these two, either the plus case or the minus case, is going to be the acute angle bisector of these two lines U1 and U2, and the other case, the minus case for example, is going to be the obtuse angle bisector of U1 and U2. Now, what I'm going to be doing is using this knowledge here in order to find the two angle bisectors that we're looking for, the angle bisector of the angle AOB and the angle bisector of the angle OAB. Now here we can see out of the two angle bisectors, one of them for, let's say, the line angle AOB, if we consider the lines OA and OB, then if we just extend them out, we can see that this is also going to be one of the angle bisectors that we get from that formula. Now considering these two angle bisectors, this one which we don't want and L1 which we do want, we can see that for this angle bisector, both points A and B are above the line. But for the line L1, which is the angle bisector that we do want, the point A is above that line and the point B is below the line. So the point A and point B are on opposite sides of the line L1, which is the angle bisector that we want. Which means that once we get the two formulas for the two angle bisectors of OA and OB, one of them is going to have the property that the points A and B are on opposite sides of it, and that one is going to be the one that we want to find. So what we're going to do is, to do that, we're going to find the two angle bisectors, and out of those we're going to check which one of them gives us A on one side and B on the other side, and that's going to be L1. Similarly, if we consider L2, the other angle bisector that we're going to have is going to be this angle bisector, which is going to go like, if we draw these two out, it's going to go like this. So we have this angle bisector to worry about. If we consider the two angle bisectors here, we can see once again the point O and the point B are on the same side of the line for this angle bisector that we don't want, but for the angle bisector that we do want, which is the angle bisector of L2, point B is on one side of the line and O, the origin, is on the other side of the line. So once again, we're going to get two angle bisectors from that, and we need to see which one of these has O and B on opposite sides of the line, and that one is going to be the one that we want, which is L2. So now let's go down and do that. If we first consider the angle bisectors of OA and OB, angle bisectors of OA and OB are given by, if we take a look at OA and OB, we can see OA is 2x minus y, so therefore we have 2x minus y divided by the square root of a squared plus b squared, which in this case is 2 squared, plus negative 1 squared, which is going to be square root of 5, equal to plus or minus the other bit, which is for OB, x minus 2y. So we have x minus 2y divided by, once again, the square root of a squared plus b squared, which for this one is going to be the square root of 1 squared plus negative 2 squared, which again is going to be equal to 5. So therefore we get two results here. If we cancel out the square root of 5, so on this side and this side, we get 2x minus y is equal to plus or minus x minus 2y. So we get 2x minus y equals plus or minus x minus 2y, which you can separate into two cases, which is going to be 2x minus y is equal to x minus 2y, or 2x minus y equal to minus x plus 2y. Now if we clean both of these up, we can see on the first case, if we take this 2x and this x, we are left with a single x. We have x, and then if we consider this minus y and this minus 2y, we get only a single minus y on the right hand side. On the left hand side, therefore, we get an x, and on the right hand side we get a minus y. So we get x equal to minus y, or if you write it in ax plus by plus c form, we get x plus y plus 0 equals 0. In the other case, if we consider this one right here, we have 2x minus x, which is going to be 3x. We get minus y plus 2y, which is going to be 3y, which means we get 3x equals 3y, or x equals y, which if simplify down, we can get to a pattern of y minus x equals 0. So therefore, L1, the angle bisector of AOB, is either x plus y equals 0 or x minus y equals 0. Now, in order to test which one of these it is, we can actually already see, since this has a positive gradient like this, it must be the y equals x1 or the y minus x equals 0, 1. But for our test, we'll do it the correct way, and we'll consider which side of the line A is on and which side of the line B is on. So considering A and B, if we substitute A and B into here, if we call this first line V1 and we call the second line V2, then we can see for the line V1, if we substitute in the coordinates of A and B, for A, we have x equals 1 and y equals 2. So therefore, we have 1 plus 2, which is equal to 3, which is greater than 0. And if we then consider B, we get 5 divided by 2 plus 5 divided by 4, which is going to be equal to divide by 4, common denominator, and plus 15 on top. So we get 15 divided by 4, which is greater than 0. So both of these are positive numbers, and since both of these are positive numbers, we can then conclude that the points A and B are on the same side of the line of line V1. So therefore, in our diagram, since we know that L1 has A on one side and B on the other side, we know that this line V1 is not equal to L1. Now then, if we consider V2, for V2, when we do the substitution for A and B, for the point A, we have 1 and 2, so x equals 1, y equals 2, which means we have 1 minus 2, which is equal to negative 1, which is less than 0. But then if you consider B, for B, we're going to have 5 divided by 2 minus 5 divided by 4, which is going to be positive 5 divided by 4, since 5 divided by 2 minus 5 divided by 4 is 5 divided by 4, which is greater than 0. So here we can see A gives us a negative value, while B gives us a positive value. Now this means that A is on one side of the line V2 and B is on the other side of the line V2, and since V2 is one of the angle bisectors of OA and OB, this must be the angle bisector we're looking for, which is L. So therefore we can see, therefore L1 is correspondent to the line V2, and therefore L1 is given by x minus y equals 0. So there we go, we've found the first line L1 that passes through the point O, at is the angle bisector of OA and OB, or the angle bisector of the angle AOB. Now once again, similar to how we found the two angle bisectors, which is this angle bisector here, which is angle bisector of this angle, and then out of them we eliminated one of them by the fact that for this one, A and B are on the same side of this line, but are on opposite side of the other angle bisector. We're going to do the same exact thing for this line L2 and the other angle bisector, which is this angle bisector. It looks something like this here. So we can see the point B and the point O on the same side for that line, but they are on opposite side for the other angle bisector L2. So if we go down and consider that one, we can see by the similar method, we're going to actually write the exact same thing here, exact same thing as this, except for this thing, we're going to need OA and AB. So we're going to go down, we're going to write the exact same thing here, but instead of OA and OB, we're going to have OA and AB. So we have OA and AB. And this one's going to be given by, if we go up and figure out what it's going to be given by, the first line OA is 2x minus y. So we have 2x minus y, 2x minus y, divide by the square root of a squared plus b squared, which is going to be 2 squared, plus negative 1 squared, which is going to be 5, equal to plus or minus the other line, which if we go up here and check, AB is equal to x plus 2y minus 5 equals 0. So we have x plus 2y minus 5, x plus 2y minus 5, divide by again the square root of a squared plus b squared, which if you look here, we can see we're once again going to get 1 squared plus 2 squared, which is going to be square root of 5, and therefore if we cancel out, we can see we have two cases. Once again, we have case 1 where we have 2x minus y equal to x plus 2y minus 5, and in the other case that we have 2x minus y equal to minus x minus 2y plus 5. Now if we solve them, we can see for the first one, if we take the x from both sides, we have x on the left hand side. Taking the other y to the other side, we have 3y. So we have 3y minus 5 equals x, which means if we take everything to one side, x minus 3y plus 5 equals 0. And on the other side, if we take the x's to one side, we have 3x, and then we have minus y, and then minus 2y to the other side becomes plus y. So we have plus y, and plus 5 to the other side becomes minus 5 equals 0. So these two are the two lines that we have. Let's call this line, let's say W1. So W1 given by x minus 3y plus 5 equals 0. And let's call this line W2. So W2 given by 3x plus y minus 5 equals 0. And if we consider these two lines, then we can do the same exact check that we did earlier. And using that check, we can see which of these two is the correct line. So if we consider W1 and we consider the points that are relevant here, which in this case, if we go up, the point of the origin and B are relevant here. Since if we consider L2, for L2, origin is on one side and B is on the other side. But for the other perpendicular bisector of this, not perpendicular bisector, angle bisector of this angle here, we can see for AB and OA, this thing has both the origin O and the point B on the same side of the line. So if we go down and consider like that, like exactly like we did up here, for the point B and for the point O, which is the origin, and then if we do the same thing for W2, we consider B and the origin. Really one of these is enough, but we'll do both. For B, if we consider B is 5 over 2 and 5 over 4. So we get x, which is 5 over 2 minus 3 times 5 over 4, which is 15 over 4 plus 5, which I'm going to write as, actually we'll write as this for now, which is, if we simplify, we have to take common denominator of 4 here. So we have divide by 4, and then here we have 10, here we have a 20, so we have 30, minus 15 is going to be plus 15, so plus 15, which is greater than 0. Then if we consider 0, we have 0 minus 3 times 0, which is 0, plus 5, which is equal to 5, which is greater than 0. So therefore, W1 is not the line we are looking for. Now instead, if we consider W2, we can see if we substitute into W2, for B we get 3 times 5 divided by 2 plus 5 divided by 4 minus 5, which is going to be equal to, if we take common denominator of 4, on top we're going to have 30 here, we're going to have minus 20 here, that's going to be minus 30 minus 20 is plus 10. And then plus 5, which is going to be 15. So we have plus 15 over 4, which is greater than 0. Interestingly, the same exact value as we had for W1. Now, if we consider B, origin instead of B, we're going to have 0 plus 0 minus 5, which is going to be minus 5, which is less than 0. So we can see for B, we get a positive value, but for the origin, we get a negative value, which means that origin and B on either side of the line W2, which means that therefore, we can say that L2 is the line W2, and therefore finally L2 is given by 3x plus y minus 5 equals 0. So 3x plus y minus 5 equals 0. So there we go. We found the equation of the two perpendicular angle bisectors of L1 and L2. Now after this, the question then asked us to show that the intersection point of the lines L1 and L2, which we've just found, is equal to the point D, which is 5 over 4, 5 over 4, and then it asked us to find the perpendicular distance from D to the line OA. So if we consider doing that, for the two lines, which is L1 and L2, where L1 is x minus y equals 0, L1 is x minus y equals 0, and L2 is 3x plus y minus 5 equals 0, we can see from the first line, we can see that x equals y, which is 1, and then we can take this as number 2. If we combine 1 and 2, we can see that if we substitute x for y, we are going to get 3x plus x minus 5 equals 0, which means 4x minus 5 equals 0, which means that 4x is equal to 5, which implies that, of course, x is equal to 5 over 4. And if x is equal to 5 over 4, then from 1 we can see that y is also equal to 5 over 4. So the point x equals 5 over 4 and y equals 5 over 4 is the intersection point of L1 and L2. So we can say that therefore 5 by 4, 5 by 4 is the intersection of L1 and L2, and we can also say that this point is what we call D. So we can say the point D given by 5 by 4 comma 5 by 4 is the intersection point of L1 and L2, which, as we defined previously, L1 and L2 are the two angle bisectors that we wanted. We wanted L1 to be the angle bisector of AOB and L2 to be the angle bisector of OAB. So now we have those two, which means that we've completed that part. Now for the final part, where we need to find the distance between D and OA, it's quite simple. For any line of the form AX plus BY plus C equals 0, as we know from the straight line video that we did previously, for any line of the form of this, the distance, the perpendicular distance of a point, let's say H comma K, from this line is equal to absolute value of AH plus BK plus C divided by the square root of A squared plus B squared. So this is the theory that we're going to be using. We should write this in a box or something like that if we want to make a reference to it, and then we can then apply it to this particular case, which if you go up, we know that OA, the line OA is given by 2x minus y equals 0. So therefore, if we consider OA and the point D, we can then say, therefore, perpendicular distance of D from OA is equal to the absolute value of, if we substitute, we have x minus 2y, which is going to be 5 divided by 4 minus 2 times 5 divided by 4 plus 0, since C is 0 for that above line OA, and then we have to divide by the square root of A squared plus B squared, which in this case it's just 1 plus negative 2 squared, which is going to become square root of 5. So this is going to be our answer. If we simplify this down, we can see we get 5 divided by 4 minus 2 times 5 divided by 4, which is going to be negative 1 times 5 divided by 4, but when we take the absolute value, it is going to be just 5 divided by 4 and then divide by the square root of 5, which is going to be equal to the square root of 5 divided by 4. So therefore, this is our final answer, the square root of 5 divided by 4. So that's going to be all for the part 1 of this question. As I have said previously in the start, we have part 1 and part 2. I've broken it artificially because otherwise the video would be too long. So that's going to be all. We're now going to discuss the marks awarded for part 1, and then we are going to continue for part 2 in the next video. So considering the marks awarded for part 1, at the start for drawing this diagram you actually don't get any marks, but after that, when you find the equations of the line OA and OB in the standard form of AX plus BY plus C equals 0, finding OA gets you 5 marks and finding OB gets you 5 marks. AB, however, is a little bit more complicated, and due to that they've given 10 total marks, 5 marks for equating the gradients and equating y minus 2 divided by x minus 1 to this gradient given by the points of B and A, and then when you simplify it down to AX plus BY plus C equals 0 form, you get another 5 marks. On the next page, after doing all of that, when you then consider the perpendicular bisectors using this theory, when you write down the theory for OA and AB and write down that 2x minus y divided by square root of 5 is equal to plus or minus x minus 2y divided by square root of 5, you get 10 marks there. When you then simplify that down and you realize that there are two solutions, two lines, V1 and V2, for writing down V1 and V2 in their standard forms, you get 5 marks. It's not just for the correct one, it's for both. When you then simplify down and you realize one of these doesn't have the condition that we need for it to be the bisector of that angle, but the other one does, and you isolate the correct one and write that L1 is equal to x minus y equals 0, you get 5 marks. When you then go down and do the same exact thing for the other bisector and consider the angle bisectors of OA and AB, writing down this equation right here gets you a total of 10 marks. Simplifying it down to get the two solutions gets you 5 marks for both of them, of course. And then out of these two lines, when you find the correct one using any proper method, in this case we've done the B and O being on one side versus opposite sides method and gotten the correct answer, you get 5 marks there. Now after this, when you then find the intersection of L1 and L2 and do all of this work, when you get x equals 5 over 4, you get 5 marks, and when you get y equals 5 over 4, you get another 5 marks, which I don't really know why they did this instead of giving 5 marks for the two answers. and 5 marks for the method or something, but hey, that's how they've given it. So 5 marks for x and 5 marks for y, they're both equal to each other, and that gives us the point that D, which is 5 over 4, 5 over 4. Now after that, when you finally consider the perpendicular distance from the point D to the line OA and you solve all of it, for all of your solving and getting the correct final answer, you get 10 marks. So with the theory, when you substitute and do all of the solving, you get 10 marks. And that is all for part 1 of this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.